origin lies in the proper use of simple hand tools. But to more fully appreciate these tools and their part in our world today, let's turn back the pages of history. 60 or 70,000 years ago, long before the beginning of civilization, our primitive ancestors lived in caves, and we today might also be living in caves, except for a certain event that took place within the gloomy depths of this long-forgotten cavern. Here, a certain Stone Age craftsman by the name of Primitive Pete stumbled upon a very good idea. He suddenly realized that by fastening a stick to a rock, like this, he could extend the length of his arm, like this, and thereby greatly increase the force of his blow, like this. Thus was born the world's first practical hand tool. Oh, did we say practical? Well, anyway, it was a good idea. In fact, it eventually led to the development of all the numerous sledges and hammers we have today. But more than that, out of Pete's Stone Age hammer came other tools, tools for every purpose. This ball-peen hammer, for example, is just a practical version of Primitive Pete's first crude invention. But like all tools, there's a right and wrong way to use it. There are still Primitive Petes among us today who would abuse this fine tool. And this would be the horrible result. Obviously, this hammer was never intended for crushing rocks. The ball-peen hammer was designed for many purposes. The peen end can be used for riveting. It's also used for shaping soft metal. When using the face, you can avoid damage when hitting a hard object simply by striking with a full face. Never strike the object with the edge. Of course, there are many other types of hammers, all based on the original Stone Age model. There's the brass or copper, the rawhide face, plastic tip, and the claw hammer, which is the most commonly used, or we should say most commonly misused. To use the claw hammer correctly, rest the head squarely on the nail. Give the nail a slight starting tap, then drive it in with steady blows. A long nail can be pulled part way with the natural leverage of the claw. Then a block of wood placed under the head will increase the leverage, making a stubborn nail easier to pull, with less strain on the handle. A hammer with a loose head can be plenty dangerous. Here's how Primitive Pete would tighten the head on his hammer, but that only damages the handle at both ends. Have you a little beauty like this in your home? A steel wedge is the right answer. Driven into the wood, the wedge spreads the handle to the tapered sides of the eye and holds it tight in both directions. Gripping the handle too close to the head reduces the blow and sometimes makes it difficult to drive a nail in straight. Always grip the handle close to the end to increase the length of the lever arm and make each blow more accurate and effective. Never use a handle for a crowbar. That's going all the way back to Primitive Pete. Another familiar tool that takes an awful lot of abuse is the ordinary screwdriver. Our Our modern-day primitive Pete often uses a screwdriver to pry open a stubborn window. Well, maybe he'll succeed in ruining the tool. This never would have happened if Pete had known more about the screwdriver. It's made up of three principal parts: handle, shank, and blade. Some screwdrivers have a full-length shank extending through the handle. But many household screwdrivers have a shorter shank pinned to the handle in this fashion. This type will not stand a primitive Pete treatment. The best rule is never hammer on any screwdriver. Many of us try to use one screwdriver for every size of screw head. Always choose a screwdriver with a blade equal in width to the length of the slot. Another thing, never attempt to turn a tight screw if there is too much play between the blade and the slot. A bad fit can cause serious trouble. It can ruin the screw slot or the blade. This looks like the work of primitive Pete. Well, so it is. Fortunately, if the blade is not too badly chipped, it can be reground into serviceable shape. First, grind the tip straight and square with the shank. Then grind each face a little at a time, but never allow the blade to become hot. Excessive heat will draw the temper and the blade will become soft. Here are the front and side views of a properly ground screwdriver. Here's a little trick. If the faces of the blade are tapered in slightly, a short distance back of the tip, the screwdriver will stay down in the screw slot, even when a severe twisting force is exerted. Here is a special type screwdriver designed for heavy duty. The extra large square shank will stand a wrench if added leverage is needed. Don't be a primitive Pete and resort to the use of pliers. They're apt to chew up the shank. Pliers are made for other purposes. Here are some familiar types: combination, diagonal cutting, long round nose, and side cutting. These side cutting pliers are used chiefly for electrical work. To make an electrical connection, first cut the insulated wire to the required length. Then use the parts back of the joint to flatten the insulation, like this. Then grip the insulation with the cutting edges without biting into the solid wire and strip off the insulation. Now right here is where long round nose pliers come in handy. To make a neat loop to fit a terminal, first use the tip of your pliers to make a right angle bend. Then grip the wire farther up and turn the end into a loop. These diagonal pliers have their cutting jaws at an angle. They're very useful for removing and installing cotter pins. A drop of oil every now and then is good insurance against rust. Like all tools, pliers should be kept in good working order. These combination pliers, equipped with a slip joint, are very commonly used. They usually have a small shear between the teeth and the joint for cutting wire or nails. Think of these pliers as a set of extra, stronger fingers, valuable for all sorts of jobs. They should not be used to tighten or loosen nuts. The jaws might slip, chewing off the corners of the nut. A better tool for this job would be an open-end wrench. They usually come in sets, with openings ranging in size from 5/16 of an inch to 1 inch. Wrench measurements refer to the distance between the jaws. Use a wrench that always fits the nut exactly. Pushing on a wrench when the nut is tight is bad practice. Better not, Pete. We're warning you. Oh! Well, some people have to learn the hard way. On open-end wrenches, the head is set at an angle to the handle, usually 15 degrees. This permits efficient use in close quarters. For example, this nut has very little swing space around it. To start the nut, the wrench will fit one set of flats in this position. And we can give the nut a partial turn before the handle jams against the block. But if we try to repeat the action, we find the nut is in a new position and the wrench won't fit. So we flop the wrench over and get a new fit on the nut. Again, we pull the handle as far as it'll go. We keep repeating the procedure until the job is finished. An ingenious development of the open-end wrench is this type. Its adjustable jaw makes it handy for many sizes of nuts and bolt heads. But the jaw should always be set for a snug fit on the sides of the nut before exerting any great force. To use the wrench correctly, the pulling force should be applied to the stationary jaw, like this. Great force applied to this weaker adjustable jaw might ruin the tool. This type of wrench is not intended for hard service, so don't overstrain it. And remember to keep the moving parts well oiled. There are many uses for a medium-sized monkey wrench. This tool also is often abused. The jaws should always be adjusted to a tight fit. And remember to exert the pull on the right side, opposite the opening. If the wrench is used the wrong way, it might slip off the nut and do a lot of damage. See what we mean? Trying to force a stubborn nut by hammering on the handle of the wrench is a sure sign that you're a primitive Pete. If you really want to ruin a good tool, try this on your monkey wrench. You can ruin yourself, too. What Pete needed was a bigger wrench. And we should remember that there is a proper tool for every job, if we'll only take the trouble to use it. Pipe wrenches are used for turning pipe fittings, and other round objects. The teeth of the pipe wrench will not grip the fitting unless the tool is worked in the correct position. For best results, the bite should be taken at the center of the jaws. Remember, the teeth will always leave their mark on the work. However, if you must use a pipe wrench on plated fixtures, you can first wrap the pipe with a leather strap. This will protect the finish. A popular wrench with mechanics is the box wrench, designed for use in close quarters. The 12 notches in the head of this tool make it possible to get a good fit over the nut in almost any position. notice the nut is gripped at all 6 corners. To ensure a working clearance, the head of this wrench is offset from the handle at a 15-degree angle. Some mechanics call this tool a knuckle saver. Here's a combination of a box and open-end wrench, sometimes called a half and half. The box end is ideal for breaking loose a tight nut. Then, if there's no clearance for a full spin, the open end may be used to turn the nut off more quickly than the box end. Every workshop should have a set of socket wrenches with at least one handle to fit the different sockets. However, a good mechanic needs a larger set, like this one, with a dozen sockets and several handles for different types of jobs. These special handles provide leverage in almost any position. For example, this hinged offset handle can be worked at various angles. This T-handle with a universal joint allows use in very confined areas where it would be difficult to work with ordinary handles. A further improvement is a ratchet handle. With this tool, the ratchet lever can be set so that the wrench pulls in either one direction or the other and ratchets in the opposite direction. When Primitive Pete attached a simple handle to a piece of rock, he became the inventor of the first hand tool known to man. And from this beginning, through centuries of trial and error, came the vast array of fine tools we have today. Well, if it isn't our old friend Primitive Pete, you can always depend on him to misuse tools. What are you up to now, Pete? Uh-oh, just as we thought. A cold chisel is a sturdy tool, but don't try to cut hardened steel with it. Here's a tip. If steel resists filing, it is much too hard for your cold chisel. But used properly, a cold chisel has no equal for many jobs. For instance, cutting off this rivet head. Or for splitting rusty nuts which can't otherwise be removed. It's handy, too, for making a rough cut on sheet metal. Of course, there are many other kinds of chisels used for working metal. For example, the Cape chisel, the round-nosed, and the diamond-pointed. All three are shaped for certain jobs. To get the best results from any chisel, be sure the chisel is big enough for the job. And always use a hammer big enough for the chisel. Above all, be careful of flying chips. And never use a dull-edged chisel for cutting. Keep the tool sharp by dressing the cutting edge on an emery wheel. And try to maintain the original bevel. But don't let the tool get hot. To prevent drawing the temper, dip the cutting end in cold water at frequent intervals. The cutting edge, as shown in this magnified view, should be ground to a slight radius. When the head of the chisel starts to look like this, it's time to dress it up on an emery wheel. To do a neat job, grind off the metal until the sides are evenly tapered, leaving the top comparatively flat. Searching for a tool when you need it takes all the joy out of any job. A handy rack saves your time and temper. For dozens of repair jobs around the home, a wood chisel is indispensable. For certain jobs, hey, wait a minute. Using a chisel to open a can? Who let Primitive Pete in? Uh-oh, our mistake. It's Mrs. Primitive Pete. She would be the one to stir paint with a chisel or to remove tacks or even as a substitute for a screwdriver. Here's how to use a wood chisel correctly. To make a horizontal cut, always try to work with the grain of the wood. Ordinarily, to make a roughing cut, the bevel is held down and the chisel is forced into a deep cut with a mallet or hammer. For most work, a thin paring cut is easier to get when the bevel side is up. For fine work, the chisel should be held at a low angle to the wood, slightly turned to one side, and then pushed with firm, even strokes from the worker. Your chisels deserve the best of care. Keep them sharp, polished, and ready for use. Wood planes were developed from chisels. Every workshop needs at least two types. The block plane for small, light work, or for planing end grain, and the jack plane for work on larger surfaces. For smooth operation, the plane must be carefully adjusted. If the cutting edge is uneven, sight along the bottom of the plane, then move the lateral adjusting lever, either right or left, to even up the cutting edge. It'll look like this when seen from the front end. To adjust the plane for a thin shaving, turn the adjusting nut until the cutting edge projects about the thickness of a hair. Before you start the plane, be sure the wood is clean and that all nail heads are set well below the surface. Always plane with the grain. Press down on the knob at the beginning of the stroke, then on the handle at the end of the stroke. When storing for future use, a narrow cleat on the shelf will prevent damage to the blade. Every tool kit should have at least 3 punches: a starting punch, a pin punch, and a center punch. The starting punch comes in handy for loosening rivets, pins, or bolts. Then use the pin punch to finish the job. The center punch is a mighty handy tool for punching the location of a hole in metal before drilling. If we don't make a punch mark, the drill will wander about. But if we first punch a small hole in the metal, the drill takes hold immediately. Every workshop needs a good brace and a set of bits for boring holes in wood. Hey, Pete, wait a minute. You're forcing it. Well, you almost made a hole in one, and what a hole. Now let's do it over and try to make a clean, straight hole. First, we use a tri-square to line up the bit with the plank. Then hold the brace firmly and use only enough pressure to allow the screw point to draw the bit into the wood. Now stop boring when the screw point starts to come through. Then turn the plank over and finish the hole from that side. Now, there's a hole you can be proud of. It's very important to protect the screw point, the sharp spurs, and the lip from damage during use or when stored away for further use. One of the most useful tools is the ordinary file, precision cut and made of very hard steel. Each part has a name. This is the face. This is the tang. The length of a file is the distance from the heel to the tip. A file with a single row of parallel teeth is called a single cut file. Files with crisscross rows of teeth are called double cut files. Files come in many different shapes, too, such as flat, half round, triangular, and rat tail. Before attempting to use any file, be sure to set it in a tight-fitting handle. First, insert the tang, then give the handle several hard raps. Remember, file teeth are made to cut only on the forward stroke. Lifting the file from the work on the back stroke will prevent undue wear on the file. For draw filing, to produce an even, flat surface, the file is held in this position and drawn back and forth lengthwise with the work. A slight rap on the handle will usually remove metal particles. But if your file becomes loaded with metal, it should be cleaned with a file card, like this, or a stiff wire brush. Guess what's wrong in this picture? Well, in the first place, Pete is using a rip saw instead of a crosscut saw. The rip saw is used for cutting with the grain. It has coarse teeth, usually 5 or 6 to the inch. On the other hand, the crosscut saw has smaller teeth, usually 8 or 10 to the inch. Now, Pete, do you think you've learned which saw to use to do the job right? Ah, that's better. You see how nice and clean that cutoff is? When using the crosscut saw, hold the saw at a 45-degree angle to the board and always start the cut with a backstroke. Holding the index finger along the handle helps to saw straight along the line. For sawing with the grain, use the rip saw. Hold it at an angle of 60 degrees to the wood. Use long, steady strokes, and don't force the saw into the wood. After every use, rub a little oil on the blade to guard against rust. But don't ever do this to your saw. Most of us are familiar with these other special purpose saws: the back saw, the compass saw, coping saw, and this adjustable frame hack saw, which is used principally for sawing metal. Always place the blade on the pins with the teeth pointing forward. In starting a cut, make use of as many teeth as possible. For example, to cut this angle iron, this starting position would be right. This position of the blade would be wrong. Not enough teeth on the work. The cutting action is similar to a file. So remember to relieve the pressure on the backstroke to avoid dulling the teeth. Certain jobs require a certain number of teeth per inch. 32 teeth per inch would be too fine for this job. 18 teeth per inch would get the job done with less work. But for conduit or any thin metal section, 18 teeth per inch is too coarse. The teeth would straddle the work, stripping the teeth and ruining the blade. In this case, 32 teeth would be correct, since it allows 2 or more teeth on the work at all times. When not in use, the hacksaw should be hung up to protect the blade teeth. Common sense care applies to all our tools. A place for everything, everything in its place. That's a mighty good slogan. Down through the ages, since the first Stone Age hammer, the proper use of tools has been the rest. Today, all the miracles of modern production have their origin and their inspiration in tools. So let's have a new pride in our use and care of hand tools. Let's give tremendous importance to the onward march of progress.